Okay, everybody, welcome back to Artificial Intelligence for the second interactive weekend. And what you're looking at is a copy of the textbook. And you're looking at it because I want to get to the index. And on the index of the book, we're going to see the chapters, hopefully, if I get there. If I finally get there. Hold on one second. Let me just move ahead. Here we go. I want to show you the index of this book here to show you the topics that are going to be on the final exam. So tomorrow, we have a class meeting. Starts at 10 o'clock in the morning. So today started at 9, but tomorrow starts at 10. Sunday starts at 10, just to give you the revised schedule. On Sunday at 3 o'clock, you have a final exam. The final exam is going to include the content I'm going to tell you right now. But because we're missing so many people right now, after lunch, when we come back at lunch, I'm going to go through each one of the questions. But right now, for those people who are anxious to know, because usually people show up, I want to know what's going to be on that final. I'm going to tell you right now, it's based on the last weekend that we had. So it's going to be covering really primarily the focus on the first part of the course. There are a couple of questions that are going to be from this weekend, but 2/3 of it is on the first weekend. And what did we do the first weekend? We did chapter number 1 and chapter number 2, chapter number 3. So chapter number 1, just to refresh your memory, because also this is a nice introduction to the weekend as well. We covered agent theory and what an artificial intelligent agent is, the different types of agents that you have experienced so far in terms of, and I'll review this in a few minutes. But there is one question, actually I'll just go ahead and do the final exam review right now, and then I'll do it again after lunch. Because you guys were, this is your reward for showing up on time on Friday. You get to know what's on the final. So, all right, so first question is on chapter number 1. It is a 2-point question, and it is on the information that's covered here. So if you don't have the book right now, probably tonight or tomorrow, you probably want to read the book, read the chapters that I'm talking about. Not the whole book, but you want to read chapter number 1 to start out with. It's on the concepts of artificial intelligence, the state of the art, what it is, how it's used, and the crossover fields. So you want to, at least read this chapter. It's pretty light reading, and it's actually kind of interesting as well. Question number 2 is a 3-part question, and it comes out of chapter number 2, which is on intelligent agents. So at a minimum, you want to be familiar with the concept of the agents and their environments. So agents and environments, agent behavior, the concept of rationality, nature of agents, the structure of an agent. And I'm actually going to skip, I'm going to go to chapter 2 here, page 34. Maybe there's a way of going. How about go? Go to page. Excuse me? It is not multiple choice. I tried to do it multiple choice and I couldn't do it because it was too easy. So none of the questions are multiple choice, they're all short answer. So is that subjective or is that? Subjective. That is subjective. We don't use those terms, so it's definitely an international term. Subjective is fill in the blank. It's not fill in the blank, it's short answer. Brief answer, not essay. As an example, I'll read you part of the question, of question number 1. AI research and applications, blah, 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 identified 2, blah, 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 include an example of blah, 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 blah. And then when I say, I'm going to read you the question, people are like, yeah, really? Okay. Yeah, I'm ready. Blah, blah is spelled B-L-A-H, space B-L-A-H, by the way. Yes? No, but come see me at the break and I'll talk to you about it. So chapter 2, what you're looking at right now, there's PDF versions of the textbook that are available for you to get legally online. So there's also the printed text, but right now you're not probably going to be able to get a printed text because right now you're probably, unless you're going to run out to a bookstore and buy it, you're probably going to get an electronic form of it. So, but talk to me at the break and I'll explain. So you want to know about agents and their environments. What's an agent? And the different types of agents. So what you're looking at here, and this is a good review, actually, this is going to also serve as our review of the first weekend if you've missed anything. What you should have learned was the concept of the agent, perceiving environments through sensors and actuators. So they act upon the environment through what's called actuators or actions. So they sense something from the environment, and then they do something with it, and then they act upon it, and then that's how the agent essentially lives. That's the life of the agent. So the term percept, which refers to the perception or the inputs of the given agent or the instance. Here's an interesting diagram here. It's on agents that interact with their environment through sensors and actuators. This is the part I'm going to ask you about. I will specifically ask you about this big old question mark in the middle of the page here. I'm going to give you an agent scenario. In fact, I'll read you the parts of one of the questions here of number 2. Provide the details, graphically or in words, for how to create a complex blah, 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 blah agent. Actually, I'm sorry. It was not the word complex. I meant to say complete. So, provide the details either graphically or in words for how to create a complete blah, 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 blah agent. Fill in the blanks. There's 3 of them. You might guess for 3 different types of agents. You can do it graphically, or you may do it in words. If you're going to do it graphically, take a look at this graph here. Actually, better yet, take a look at, this is a vacuum cleaner agent example. I believe there's a graph here where it's filled in. Maybe it's also in chapter 2, we'll see. Let's see, let's continue. Hold on one second, let me find the, here it is, this is what I'm looking for. Oops. This one here is a model-based, goal-based agent. It keeps track of the world states as well as a set of goals it's trying to achieve, yada yada. This is what I meant by graphically. So you can draw it out like this if you'd like, or you can put it in words. If you put it in words, you'll have to say, make sure that you do it for the theme that I'm giving you. I'm going to give you a type of agent. As an example, let's just use this one up here, the vacuum cleaner. I'm going to say, create a utility-based agent for the vacuum cleaner. Or create a complete solution for a goal-based agent for the vacuum cleaner. A utility versus a goal are going to give you 2 separate types of agents. So when you describe this graphically, and this one here, I don't even know what this example here is for, but here's one. This is a semantic graphic of a simple reflex agent, not for a particular theme. It's just a reflex agent. And then I believe there's one in here that gives you an example. Here's a model-based reflex agent. Add the theme. There's a couple of them in here that might actually have themes in them already. What is this? Utility-based agent. Here's a model-based agent. That's the one I was looking at before. So what does an agent do? It takes in, let me just explain this graph to you for those people who have missed the first weekend. This is why you want to read this chapter. It is chapter 2, by the way. We have an environment, and I'm going to talk about environments actually in a different question. You will have a question about environments as well, but hold that thought for a second. The agent perceives stuff in its environment. What does it perceive it through? Cameras, input. Cameras, hearing, tasting, smelling, a vacuum cleaner. Let's just use a vacuum cleaner as an example. It's going to sense dirt. So it's going to ask at the beginning, is there dirt? Let's look at a goal-based agent. So I'm going to describe a solution for you that's going to be a goal-based agent for a vacuum cleaner. So number 1, I got goal-based, and number 2, I got vacuum cleaner as the theme. So here's my solution. If I were to write it out graphically, this is a utility-based. So let's go to the goal, so I can show you here. On a goal-based agent, or probably here's a goal-based model. It's going to be the same, but some of the questions are a little bit different. I'm going to perceive through my sensors things, and don't necessarily have to list out the sensors, but I can say, big question I'm going to ask myself if I'm the agent is there dirt? Because my goal, if I've identified it, if I'm a vacuum cleaner, is to clean up the dirt. My utility, if I'm a college student, is to get a good grade, maybe? Or what was my utility? To show up to class? My utility as a construction worker is to make stuff with hammer and nail and use tools as a utility. The goal might be to complete the house that I'm building. So if I'm a vacuum cleaner and I'm a utility vacuum cleaner, I'm going to be able to suck dirt. I'm going to be able to move around from room to room. That's not really, I'm not a goal-based, I'm just a utility-based at this point. So I don't really care about cleaning up dirt. So make sure what I'm trying to tell you is make sure you focus your answer on the utility or on the goal or on the action or reflex or whatever happens to be the theme that I'm going to give you. Okay, let's go back to a goal-based vacuum cleaners. I think that's my theme I started out with. All right, so I'm going to look at the current states. So it's state-related. And then I'm going to have condition, or if I'm a utility, I might have a condition. If I'm goal, here I'm just not really going to have a condition action kind of thing. Utility-based usually has a condition with an action that's associated with it because I have a utility. My utility is to make sure the bathroom's clean. So if there's stuff on the floor, I'm going to pick it up. Maybe I shouldn't have used a bathroom as an example. If there's dirt in the sink, I'm going to wash the sink. The utility is based upon the condition that I'm running into. On a goal-based agent for a vacuum cleaner, the first thing I'm going to do is look at the states. What the world is like now. Is there dirt on the floor? If there is, how the world evolves, meaning what it will look like if I do action A. And action A is going to be suck. So you can define some actions like suck, move left, move right, turn on, turn off, any kind of actions that might be associated with the theme that's given. So what my actions do is going to lead hopefully to this goal that's down at the bottom. And the goal is what action I should do now to make myself get further to the goal. And that would be, if there was dirt on the floor, suck the dirt. If there's no dirt on the floor, move to another room or move to another. And if you can go room by room, you can go, how people vacuum. I gave you this example last time, actually. Maybe don't vacuum the same way everybody else does. Other people do like straight lines, and they go this way, and then some people go this way. There's whole different techniques to the psychology of vacuuming. But long story short, you're going to move. You're going to move left. You're going to move right. So you can explain these things in any terminology with any types of actions that you want. But that's sort of what I'm looking for in question number, it's actually question number 2 that I'm looking for this. So you can draw pictures if you want, and the pictures will look kind of like this. You can write it out in words if you want, probably whichever you prefer. But you're going to be asked for, let's see. Oh, I misled you. Only 2 different types of agents. So there's 2 agents that you have to talk about in terms of providing either graphically or in words a complete blah, 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 blah agent. Okay, so that's number 2. The first part of number 2, which is in 3 parts, is it's a question where you're going to fill in boxes talking about an agent. So it's a basic agent question, and then you're going to apply it to 2 separate agents that you're going to design. So at a minimum, read this chapter. Read chapter number 1, read chapter number 2. Question number 3 is on P's. So we're looking at, if I could just put P's in here. We have page and P's, if you remember from the first week, from the first weekend. Let's see, it's probably going to be in chapter 3. Talking about agent environments, by the way, which is what P stands for. It stands for performance, environment, actuators, and sensors. So it's just the, actually here it is here. Here we go. Performance, environment, actuators, sensors. Remember this little chart here? I'm going to give you one of these charts here. This is a big giveaway. I'm going to give you a theme. So this one theme says taxi driver. You're going to have to learn this anyway in order to fill out the second two parts of this question. I'm going to put something else in here. You know, like ITU instructor or something. I don't know. Or like construction worker. Or I don't know. It'll be something else. And you'll have to fill out this chart. That's actually question number 3. The exam is pretty easy, which is why I'm giving, well, it's easy now that I'm giving all this stuff. Question number 4 is an environment question about all the different types of environments. So let's just go here and type in accessibility because that's one of the environment types. Let's see if I can spell it correctly. I don't think that's what I really wanted. Oh, let's go back up here to, let's put in observability. .49 looks a little bit better. There we go. And lo and behold, I got to the environment section. This is also, I believe, this is also chapter 2. Which is going into the structure of the agent. And then we have something is observable being non-observable. Let's do this here. Let's type in environments. That's chapter 1. Oh, this is good here. Nature of environments, page 40. So let's see. Probably should have just gone to page 40. Here we go, the nature of environments. What I'm looking for is that list of the accessible versus inaccessible. Oh, it's not here. Here it is. Here's the list here. So section number right underneath figure 2.5, section number 2.3.2, properties of task environments. There's going to be a question that's going to ask you about the relationship between observable and non-observable, deterministic and stochastic, episodic versus sequential or non-episodic, static versus dynamic as a concept, known versus unknown. And here's a little chart here that kind of puts it all together for you. This section also has a question on it as well. So a lot out of chapter 2, actually. Heavy focus, because that's really what we covered, big old agent theory. So that's really what we covered a lot about. And I know I covered that well last weekend. So I wanted to be fair on the final. So let me go back to the table of contents for the other questions, because the other questions aren't quite as easily kind of like identifiable like that. They're broader questions that are covering more content. So those are the specific questions that I just gave you. It's covering pretty specific information. Now we also have 4 miscellaneous questions that are coming out of the other chapters. So there's not too many questions on the exam. It's only 3 pages long, actually. But they're some of them are very detailed, other ones are higher level. What do you call that? Is that subjective, higher level, or I don't know, more abstract questions? One of them comes out of chapter 3, problem solving and searching. It's about the different types of searches. It is not a detailed question, which means I'm not going to ask you about the, design a searching solution for something. Not like that. It's going to be a theory question. Actually, the question goes out and says, what is blah, 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 blah? So it's more of a definitional type question. What is? It's actually asking you about a difference. So if you have to know 2 of them in order to make a difference out of it. And so what do we have in here? We have uninformed, we have informed, we have heuristic functions. Nothing about A star, nothing about heuristics actually. It's about searching. So searching for solutions, page number 75. Oh, look at that, it goes to it. Ah, I love this. So page number 75. So I'm sort of used to PDF readers. This is the preview from on the Mac side of it. I'm like, this is great, more functionality. Searching for solutions, expanding, generating, how to search, looping path, redundant paths, and all the different kinds of searches. I actually kind of went through some of this as well the first weekend. And we covered searching in terms of, do you want to go breadth first or depth first? Breadth first searches, the first level, and then goes to the second level and the third level. It's a top-down, kind of first in, first out kind of an approach to it. Or depth first as an example, which takes and finds the longest path, the deepest path, and searches that one first. And then it goes back and searches the shorter paths. That one's more of a, it's not actually a last in, first out, actually. It's a depth first that I just described. We have informed searches, which takes and looks at some information before it starts the search to make a logical determination of where it should start and what is the most likely path. We have uninformed searches, which is the breadth first is uninformed actually, because it just starts randomly. First one, next one, next one, next one, next one. It doesn't have any information it goes by. There's no priority, there's no prejudice in terms of where it's going to start and how deep it's going to go in different areas. So that's like uninformed in a category. Searching strategies, infrastructure of the searching algorithms. No such algorithmic questions. You don't have to write an algorithm. There's absolutely no pseudocode writing on this exam either. And there are absolutely no questions on Prolog or Scheme or Lisp in this exam either. And no genetic algorithms on this exam either. For all of you guys who actually did the assignments, you know that the assignments are probably much harder than this exam. So I went easy on the exam, sort of like I tried to go easy on the Oracle exam, because you don't really have time to study for it. Because you only have 2 weekends, and it's the third day of a second weekend, and you're in class all day, so what are you going to do? So, and I don't want to do, it is a closed book, closed notes. So it's easier because it is closed book, closed notes, closed internet, closed everybody. So those people who say, oh, I wanted an open book, open notes, then I'll have, if I were to do that, I'd have you write trees and write solutions and write code and write this, and then I don't think you want that. So for those people who complain, oh, it's not open book, you don't want it to be open book, seriously, because then the questions are going to be so hard you can't find the answers. So, lo and behold, here's the depth first I was just talking about. And the breadth first is up here, and we have other ones in here too. We have tons of different types of searches in here. Here's the depth limited search, iterative, depthing first search, depth first search. So go ahead and read through this one. This one is chapter number 3, which is a good starting point for searching. So let's see what else you need to know. Oops. Go back up here. Problem solving. Here we go. So beyond classical search, you do not have to read chapter 4. So 1, 2, and 3 so far. You don't have to read chapter 5. You don't have to read chapter 6. On chapter number 7, I'm going to talk about that today. In fact, as soon as I get done with this review, my first lecture is going to be on knowledge engineering and expert systems. We already did the agent part of this. This is knowledge agents, the WAMPUS world, if you remember that. The logic. And logic is why I used Prolog. It was actually the logic information. Propositional logic, which is all Prolog. Predicate, propositional scheme, and Prolog, and those languages. Those languages were supposed to give you the information that was supposed to be covered in the logical agents and working with logic. Do not have to read number 7. There is a question on logic. one question out of this chapter, one question out of chapter 3. That's why I say this, it's overview question. It's not specific, and it's something where it's going to look at some concept that was covered in the chapter. So you don't have to read it in a lot of detail, but know what the concepts are, because it's going to give you a better understanding to be able to answer the question. Nothing on first order logic. You do not have to read chapter number 8 or chapter number 9 or chapter number 10 or chapter number 11. However, let me get to the expert systems in here. Learning. Knowledge, learning, knowledge, explanation. Hold on one second. I actually covered natural language processing last week as well. There is knowledge in learning, number 19, explanation-based learning, but it's not learning focused. There's a knowledge representation question, is what I'm trying to get to. I'm trying to figure out which chapter. Knowledge representation. Let's talk about chapter 12. Events, categories, objects. But the question is on the line of expert systems. The text doesn't actually get into the concept of the expert system that I'm going to be lecturing about this morning. So you guys are lucky that you showed up, because you're going to get the content needed for the expert system question that's going to be on the exam. It has to do with knowledge engineering and knowledge representation. But the text, this author, he doesn't actually get into very much expert system material. But there is a question on knowledge representation and expert systems. But I haven't covered that material yet. I'm going to cover it right now. Actually, that's next, or first on the agenda for today. But that's the entire exam. So what are you going to read here? You're going to probably focus on the lecture I'm going to give you and the concept of knowledge representation. And you're going to get the knowledge representation stuff out of the logical agents chapter here. It's a knowledge logic representation kind of question that deals with expert systems. Let's see if this actually has any expert systems in it. Oh, there's the concept here. Oh, yeah. 633. Expert systems. Decision making. So it is in here. Okay, so it is not covered until chapter 16. So this is the newer version of the book, and the older version of the book, I believe it was located earlier on, and it was in its own separate chapter. So he's moved it, renamed it, but the material is in here. It is section 16.7, Decision Theoretic Expert Systems, Theoretic Expert Systems, and the building of an expert system, and what is needed with that. Nice little picture here. You won't have to draw a picture, you won't have to describe an expert system at all, but you'll have to talk about the concept of knowledge representation in terms of expert systems. And I'll talk probably a little bit more about that, and I'll practically give you the question when I go over the lecture next. So. Questions about the midterm exam. And that actually is a pretty good summary of it. In fact, so I don't have to repeat it after lunch. So I'm going to use that. And so those people who missed it this morning, after lunch, they can go listen to the video, because this is being recorded. And if I have audio and everything that's recorded correctly and it works, this will serve as the final exam review. So it's not too many questions. Those were the chapters you wanted to read, and that's the information. So we really only have one. Today is important because today's material is covered, because it's like can't not put anything from the second weekend. But tomorrow's material not really covered, and Sunday's material is not going to be covered. How can I give you material in the morning and then give you an exam on it in the afternoon? It doesn't work out too well. So I've actually kind of saved the fun stuff about artificial intelligence for this weekend. I've saved the fun stuff for tomorrow and for Sunday as well. So, questions, comments, concerns about the final exam? Then while I have this video running, I'm going to take a few minutes and go over the assignments and things that are needed between now and the rest of the course as well. So this is, I'm trying to close this, but it's not closing. There are 6 questions total, but a couple of them are 2-part and 3 parts. I'm sorry? Yes, multiple parts. There we go. I could put it this way. So let's go back in and take a quick look here. And actually, the easiest way for me to look at it is through the LMS. So I'm going to go ahead and show you the LMS gradebook. Actually, let's see. Let's just look at the do a recap on what was due and what you should have turned in by now. And this is actually a good way for me to tell how many people actually turn stuff in. So this is the teacher's version of the LMS. If you haven't seen it yet, sort of looks like this. So far, you should have turned in take-home assignments number 1. Well, this is interesting. We have 69 people in the class, and only 47 of them turned in work. And there's no excuses unless you're here right now and can tell me that you had problems uploading it. Nobody else is going to, you're done. We're done with this one. It's overdue already. You can't upload it anymore. So this one was due yesterday, I believe, or is today the 8th? Today is the 9th, so it was due yesterday. So we had assignment number 1, 2, 3, 4, all the way up to 4 that was due on 10/8. So about 20 people are going to fail this course, it looks like, because they're going to miss out. Well, they're not going to fail. They're just not going to get an A. They're probably going to get a C or a B at best, right there on the assignments. So we have a take-home assignment number 5 and take-home assignment number 6, not due until December 14th, which is the last day of the term. So you have some time on number 5 and number 6. And we have the CSLO essay, which wasn't up there before, which is now. So I'm going to actually download it from here. The assignments are in here. So this is number 5. And I'll put this on the desktop. And then we have, so I can go over these assignments with you right now. And these are the things that we'll be working on in class, by the way. Take-home assignment number 6. And we'll put that one on the desktop. And we have the CSLO essay that is also due on the 14th. So I believe there's 4 items total. And we have the midterm exam, which is also due at the end of the course. But the midterm's harder than the final. It's a take-home. That's why. That's why you don't want open book and you don't want take-home. It's easier just to do it in class. And you see from the first weekend we had 6 in-class assignments. Maybe there's only 48 people in the class is what I'm thinking. Because only 48 or 49 people showed up. So this is actually kind of right then. You guys all turned everything in. There aren't 20 people missing. But I have like 69 people or 70 people on my roster. So those people, I guess, are going to fail the course. You might notice that I took out, if you're not in the Oracle class, this is new information for you, I took out the in-class assignments for the second weekend. So you don't have to do 6 more in-class assignments. Just like the Oracle class, instead we're going to spend the time allocated for working on assignments and things to working on those things that I'm going to go over in the next few minutes here. So this weekend is assignment number 4, assignment number 5, take home, the CSLO and the midterm, which are the 4 items that are going to be due. And the 4 items here are listed with the due date. Hopefully I'm just checking this as well. The 14th, the 14th, the 14th, the 14th. So 1, 2, 3, 4 items that are due on the 14th. The final exam, it says the 14th, but you're going to do it this weekend. So it's not something you have to submit. Are we good with what we have to do? Good? So what do we have to do? Let's take a look here. Assignment number 4, assignment number 5 and assignment number 6, the CSLO, which I'm going to go over next, and the midterm. Let's do the CSLO first. So I'm opening up the CSLO exam that I've downloaded from the LMS. You can also get them on beahacker.com, by the way, as well. This one is going to be an essay. It was not available until a couple of days ago, by the way. So if you were looking for it, it's here now. Actually, one of my students pointed it out. I wasn't even aware that it wasn't uploaded. So it's a 2 to 3 page double-spaced essay of a selected topic. You're going to freak out when you see these topics. You're going to go, what in the world are these topics? These topics are kind of hard, actually. Except for topic number 8. Select a topic of your own where you design and implement or evaluate a solution to a problem. What I'm looking for, and I'll talk about question number 8 first. I want you to select a topic where you're designing and implementing or evaluating a solution to a problem. The purpose of the CSLO essay and the purpose of this class actually is not to teach you everything there is to know about artificial intelligence. It's to make you aware of how to problem solve using artificial intelligence, and you're solving problems, by the way. Every one of your assignments have been dealing with problem solving. So in the CSLO essay, what the purpose is pick a problem. You can use an agent to solve it. You can use a search to solve it. You can use a genetic algorithm to solve it. Pick a problem-solving approach that you like, that one that you found. It doesn't even have to be one that I spent a lot of time going over. It doesn't have to be anything in the book. It doesn't have to be anything. It could be something totally that you've heard of, that you've used before if you wanted to. And solve a problem. So if I go through some of these other ones, you'll see what I'm talking about in terms of problem solving. If you don't like topic number 8, which how could you not like that one? You can use number 1 through 7. Just select one of these topics. The requirement is 2 to 3 pages double spaced, which is 1 to 2 single spaced. So it's not that much volume. However, you have to use your own words. I changed the wording so it says you must provide your own words. Before I said you must use your own writing, and people said, does it have to be handwritten? That's not what that meant, handwriting. You know, people thought it has to be in your own writing, that it was supposed to be handwritten. That's why I changed the wording now. It says, I know it's just a translation. Maybe they're just joking with me. I don't know. But they sounded pretty serious when they were asking this question. So your own words means you write it in your own words, your own writing, instead of cutting and pasting off of the internet. So eventually, I don't know if it's going to happen this term, but eventually we're going to have Turnitin.com automatically scan through your document. So nobody even has to look at it. It's going to come back and say, plagiarized. And it's going to be 0 for your grade automatically. So no humans are involved with this at all anymore. I don't know if it's going to work this time, but I wouldn't take the risk because they're just implementing it, and I haven't seen the feature yet. But it's not a bad idea to do it this term, practice it, because it's going to be checked. Who knows, maybe they'll go through and manually check it. For those of you guys who were here last term, you've already experienced what's going to happen. Hopefully. If you're brand new, just know that there's going to be plagiarism checks on your work to make sure that you're actually doing your own work. You're not cutting and pasting it from internet sources. I'm not asking for much. 2 to 3 pages is not much. So just keep that in mind. All right, because I don't want, because you know, inevitably someone's going to go, but I failed. I'm sorry, I warned you like 5 times already. Okay. So what do we mean by solving problems? Okay, so let's take a look at topic number 1. These, you're not going to like these. Well, some people might like these, but these are kind of sample problems. If you choose number 8, you want to make sure you're on par with the theme of at least 1 through 7 in terms of the expectation. So number 1 says, design and implement and evaluate some simple semantic web applications for applications such as, this is a semantic web application. Semantic web application for web searching, querying, multiple relational databases based on vocabulary, or discovering and visualizing conceptual relations among documents. Okay, so that's using a semantic web. Number 2 says design and implement. They all start out design and implement. Don't implement, don't write it. But you're designing and implement, you're talking about it. It's an essay where you're writing. Don't put source code, don't put an implementation in there, but you're talking about an implementation. So you design, implement, and evaluate an AI machine learning algorithm for use in the applications such as a news and an email filtering. So email filtering is a machine learning technique, by the way. Just like a semantic web analysis of querying, being able to search or query databases and things. Number 4 is a comparative evaluation of alternative AI-based learning solutions. No, it's number 3. Number 4, design, implement, evaluate deductive capabilities of a database, or evaluate tools for reasoning in a Bayesian network, or number 6, looking at systems for organizing and storing context-specific retrieval of life experiences. These are very specific topics. They're very focused on AI problem solving. Do not write a CSLO essay on the topic of artificial intelligence. I do not want a survey of what is AI. I do not want a survey on what is a neural network. I do not want a survey. I do not want an essay that talks about a topic as in you were going over to Wikipedia and finding information on a topic. That's not the purpose of the CSLO essay. I want you to pick a problem and give me a problem-solving solution for it by designing, implementing, and evaluating. So this is how you would solve the problem. It doesn't have to be your solution. It could be, this is how Google does its search engine. And this is how the heuristic is created to solve the problem. Or you can do your own. This is how the Wampus world solved the problem. So selecting a topic where you're designing and implementing or evaluating a solution to a problem. That's what I mean. Lo and behold, someone's going to give me an essay that's going to be on learning systems. And it'll be a survey about what learning systems are. And you're not going to get any points for that. Because that's too easy. You just go out and you cut and paste off the internet. Learning systems, here you go. And it's not going to work. In fact, that's not going to work either. But it's literally impossible to find any of these topics in terms of pre-written papers either, which is nice. And especially if you just come up with your own, that would probably be the best idea. You don't have to incorporate research. In here it says provide reference citations for any words, pictures, or graphics as well, that you use from your research sources. I'm not requiring a research list. You don't have to incorporate research. Some of this might not involve any research at all. If you go out there and you do some research, then make sure you give credit where credit is due. And you put a picture in here. Where'd that picture come from? Where'd that chart come from? And make a proper reference citation for it. So it's kind of a different theme on the CSLO. It's very different. It's not your describe Oracle. It's not describe, it's not survey, it's not explain. It's give me a sample problem, design and implement a solution, and evaluate it, actually. You don't have to do all three. And I don't want source code. Questions on the CSLO essay? No? You probably will have some questions as you start working on it. If you start working on it this weekend in the class, then you'll probably be able to answer those questions. You can also send me a rough draft or a final draft of your paper and say, is this what you're looking for? And I can tell you yes or no. I can also take a look at it and say, is this going to be okay to submit? And then I can preview it for you and say yes or no. That way you're guaranteed to know that hopefully, well, most likely, unless there's something else wrong with it, if you give it to me and you say, hey, is this good? And I say, yes, it is, it's perfect, go ahead and upload it into the EMS. And then 20 other students also upload the same one, you're going to get in trouble. It's not a guarantee that just because I tell you it's okay, it is okay. There's extenuating circumstances such as later we discover that everybody else gave you the same one. Just because it's okay for one person, it's not okay for everybody else. All right, what you're looking at now is the AI midterm exam, which actually should be the final exam. I switched them because I can't give you an in-class final of this nature this soon after 2 class meetings. Anyway, you're not going to like the midterm, but do your best in terms of interpreting it. And just know that what you're going to get is did you do the midterm? Did you make an attempt? There's more than one way of getting the answers correct. And the questions are going to require extensive research and extensive reading. All the other chapters that are not covered on the final exam are covered in the midterm. There's no overlap. So the midterm doesn't have anything. Maybe it does have something on agents towards the end, but I don't think it does actually. Nope, it's all on searching. So what are you going to have to do for this midterm? You're going to have to probably read the chapters I did not assign. And what you're going to do here is you're going to explain from Chapter 4 in an informed search exploration. Chapter 4, although it was not part of the final exam reading, it's part of the midterm reading. And the midterm is due after the final exam. So, and people are wondering why. Okay, so because IT requires an in-class final exam, you're really taking the midterm. What you're taking tomorrow on Sunday, not tomorrow, the next day, is the midterm exam. This is the final exam. It's switched. This one's going to be harder. So I've already had students, the midterm's pretty hard. It's not the midterm, it's the final. It's labeled the midterm because I have to do a take-home on this because I would not give you this in class. But the midterm that you're taking, the final exam that you're taking is really the midterm. It's covering halfway through the course. So just keep that in mind. When you're preparing for these things, logically, it doesn't make any sense at all. But that's the logic behind it. So, because you guys are all artificial intelligently thinking now, you have to be thinking about logic, So that's the logic. All right, so question number 2, you have a 2-player game, and you have to talk about the states and the moving. It's hard. It's going to take you a few hours to figure out what you're going to do with this. It's not due till December 14th, by the way. Yes? Yes, you can use that or you don't have to use that. If you want to, I gave you the starting point of the solution. Uh-huh. Oh, and then you put your bubbles here and you continue the same format. Yeah, you're going to have looping. That's called a loop. You might only have one. It might not be consistent. It's not going to build. Yeah? This one might be empty. This one might be empty, depending on how you draw it. What I did this, maybe I shouldn't have put this part down here. Yeah. It doesn't have to. You don't have to draw it that way. There is a solution where you can. And these are the points. Okay, you got that part. There's some looping in here. There's some, you'll have some question marks you'll put in there. There'll be some stuff that you can't fill in. That you'll have to either make a decision on it or you'll have to identify it, as the instructions will tell you. And that's a good point. You don't necessarily have to have 2 coming off of here. I probably should take those off. It's confusing maybe, but I wanted to know 8 just continues. Maybe I should put like a dozen of them in here. It goes out. Meaning, because I didn't want you to give the impression that it only goes in a straight line. The beginning does sort of go in a straight line, but it doesn't have to. So this one here is actually kind of interesting. This is the Wampus. Is this the Wampus world? Yeah, where you have these holes, and you're here, and you want to get to here, and you have to take a path through the network. And these are walls, by the way. These are things here, and you got to figure out how to get from here to here. You got to figure out how you're going to traverse through this network. And these, you can't go into these holes, otherwise you go down into oblivion. You can't get out. So it's actually kind of a fun thing, heuristic. But you have to build a tree out of it, or you have to build a solution. And then this one here, you're given the tree, and you have to kind of traverse through it. And you have to apply here a uniform cost, and you have to label it out as it's going to tell you to label it out. So it's not what I would call do it in one night. It's kind of like a thinking thing where you have to kind of digest it, read a little bit about it in the book, and apply it. And there's examples of all this stuff in the book. So the book will be an extremely good help for you. And I've tried in most cases to tell you which chapters to look at. For example, the first one is out of chapter 4. And this one here is actually right out of the book. You'll see it. And the answer is not in the book, but the heuristic is. Yeah? Correct. Uh-huh. Because you can calculate the goal, and you know if you're getting closer to the goal, if you're going away from the goal. Oh, definitely. You can look ahead. Actually, you can look ahead all the way to the end if you wanted to. So after you map that out, you're going to find the goal. So what makes this an interesting problem is you can take and map out the solution and then read the map. It's almost like people, it's the same thing we get. When you look at a road map, you're trying to travel from city A to city B. you look at the roadmap. So you create the roadmap, then you look at the roadmap and you can highlight or draw through. If you do this by hand or actually on the computer, you can just, take a marker and you can find the solution, which is the same way we do on maps. We take a marker and we go, okay, take this street, take that street. We find the direction so we can get point A to point B in the fastest amount of time or something, which is basically what you're doing here. But this isn't a roadmap. Yeah, that would be the easiest way of explaining the situation. So what you're going to do, the question is going to have you, apply the algorithm for a tree, chapter 4, starting with this node as described above. In this description, use the coordinates. So you're going to build a tree search, A plus describing the fringe of the A plus search, or A star, I'm not saying that right, and list the states in the algorithms and process the nodes from node 1.1, So go ahead and draw it out. You'll see an example of it in the text. You can use the same format. In chapter 4, you'll see it written out. You can just go ahead and use that same format if you want. And that should be sufficient. You don't have to. You can use any format you want. And that's why I say everyone's solution is going to be slightly different. No, there's not one way of doing it. If you read and interpret, if you're a human agent and you're reading and interpreting this, you're going to get different results depending upon how you're reading it. There's actually multiple solutions to this too, which is kind of interesting. I'm expecting anything you give me. There's like maybe 4 different scenarios. 3 to 4 different scenarios you're going to come up with. If you got one of them, you're great. If you didn't, I'm going to go, it's close enough. So it's effort-based. It's not right or wrong on this midterm. If this were a real in-class final exam, it would be open book, open note, and it would be right or wrong. But this is a really bad exam. Even if it's open book, open notes, and give you a time limit on it, I don't think anyone's going to finish it. So, questions on the midterm exam. Oh, you answer all of the questions. Oh, it says, answer 2 of the following questions to earn 10 points. Yes. I'm sorry. I totally forgot I did that. Answer 2 of the questions. There's 4 questions, I think. Or how many questions are there? 1. Answer 2 of the following questions to earn 10 points total, which is what the midterm's worth. No, actually the midterm, okay, here's the thing with the midterm. Let me go back to the LMS. I believe it's 19 points now. Because remember those in-class assignments I took away? I'm giving you the points for free. Which means if you turn in the midterm, it's out of 19. You only have to earn 10 of those points, which was the original grade on the midterm. I did not modify any of the assignment points except for the final exam, and I gave you bonus points on that. So we went from 10 to 19 points, I believe. Let me just verify that. This is good. Let me just, because actually this is great because we get all the questions out of the way, hopefully. Except for half the people who are missing. But we may only have 48 people in this class. We might not have 70. Because we only had 48 people who attended. So. Which is great. It means I won't have to use the microphone the entire weekend. Let's see. Artificial intelligence. See, last weekend I had to use the microphone because I had people talking in the back of the room the entire time. All right, so the midterm exam is worth 19 points as I suspected, but 9 of those points came from the in-class, so it's freebies. So do 2 of those questions and you'll get 10 points. Well, you're going to see 19 points because you're going to get, whatever you get, 5 plus 9. Is what if you only do 1 question, you'll get 5 points, 5 plus 9. So it's freebies because you're not going to have to do it in class. But you're probably going to spend a lot of time doing it to solve one of them. So the CSLO essay is worth the whole 19 points. That one got some points added to it as well. And I believe the final stayed the same. The final did stay the same. So it was just the CSLO essay and the midterm that got boosted up, I believe. Let me leave this open just in case there's any more further questions. So I believe there's 1, 2, 3, 4. There's 4 questions total, so you do half of it. Some people like trees, some people like writing solutions. So. Questions on the midterm exam? Nope. Okay, let's go to those lovely assignments. There's 2 of them. Assignment number 5 and assignment number 6. Assignment number 5 you like, because if you did number 4, you have the information already. Number 5 builds on number 4. So number 5 says write a family database from assignment number 4, which you've already done. And you're allowed to use your solution to number 4. At this time, use Prolog's list features to represent the basic facts of your family. Save it in an ordinary text file. Call it familylist.pro for Prolog. And your program should implement the following facts for your intermediate family, your grandparents, your great-grandparents, stuff like that. In other words, each nuclear family, if you don't know what that word is, don't worry about it, just is the immediate family. It doesn't really matter how you did your family tree, it does not matter. Just take your family tree, don't reinvent the wheel. Take it, put it in there, and then use a list instead of the logic theory. So you're going to create a list out of it. So the list itself is going to have 2 sub-lists, giving the names of the daughters in a chronological order, and define and this is an example essentially. So if you don't have a family, make up a family. So if you don't want to give out your real family, you don't have to give out your real family. But you're just going to rewrite the family database to put it into a list format, and then play around with it by a list. It's actually quite easy. Because you should have already got your family database. You're just converting it to a list format. So I'll let you play around with that one. Number 6 is the one you're not going to like. Well, you might like it, you might not like it. It's Lisp, and we're not going to cover Lisp until tomorrow, actually. So tomorrow we'll cover Lisp, and it's not too bad, but it's another language. You don't have to do it this weekend. However, you have until December 14th on this one. So this is, well, you have it on the other ones too. All of it's due on December 14th. None of it's due this weekend. But we'll talk about Lisp tomorrow. It's very similar to Prolog. It's very similar to Scheme. It's one of those languages, for some strange reason, I find that students don't like to learn new languages. In fact, some people freak out. Oh, Scheme, it's Prolog. This is like how it's supposed to be a computer science student. You're supposed to be like computer science students or software engineering students, so you're supposed to like this stuff. So you're supposed to enjoy learning new languages. So you'll like Lisp, actually. It's not too bad. But we already know Lisp. We actually already know it. We've already gone over it. So this is no-brainer. We'll do it tomorrow. So today we'll focus on expert systems. Actually, let me give you the layout of the land here. We're going to do, because I'm really just starting about the introduction of the weekend still. Expert systems is going to be first. Bayesian networks, which you might find interesting, actually, adding weights on networks and stuff. Neural networks, game theory, and first order logic. If we get to first order logic, there's no first order logic on the final or the midterm or any of the assignments, which is why I put it last. We might get to it, we might not get to it. Depends on how much time we spend on other subjects. But the first topic we're going to look at is expert systems, unless we have any further questions on any of the deliverables. Nope. Okay, so let me stop the video here, because I'm trying to separate it out into different parts. So this will be video number 1 that all students who came in late will probably want to look at, because it's going over everything they need to know for the weekend. And last but not least, just reiterate the point. Tomorrow we start at 10. Sunday we start at 10. Final exam's at 3 o'clock on Sunday. The time is not adjustable. I'm not the one running it. In fact, I don't even have the exams this time, which was kind of different because, see, at Oracle, I had the exams. I could have given it any time I wanted, but they're not giving me the exams. So Evelyn or someone from the administration will bring the exams with her at 3 o'clock, which means even if you wanted to take it, you cannot take it any earlier than 3 o'clock on Sunday. Yes? Oh, you have as long as you want. On the final exam? The final exam is not going to take you that long. I don't think it's going to take you that long. It's going to take you maybe an hour, hour and a half. So if you're planning your flight out, give yourself an hour or 2 hours. Give yourself 2 hours, 3 hours. You know, so 3, 4, 5. The class is supposed to, believe it or not, I think run till 6 o'clock. So you're probably going to get out about 4. Well, if we started at 3, you'll get out 5-ish. So let me end this video.